Hi, Assalamualaikum. In this video, we will discuss integration. In the previous video, we have been discussed question number 1 and then 2 Roman 1, question number 4, number 5 and number 6 Roman 2. Okay, so in this video, we will continue with question number 7 and 11, right? First, we look at question number 7. Integrate a definite integral from 1 to 2 sinh x over 3 plus cos x dx. Okay. Okay, this is from your lecture notes, page 118. Okay, buku yang kita guna masa kuliah kita. Alright, to solve this definite integral, we can first solve indefinite integral, okay, without lower and upper limit, okay. Kita tak payah letak dulu lower and upper limit. So, kita nak integrate yang ini. Okay, when we check from appendix, from table of integral, tengok ada tak formula untuk integrate atas dia sinh, bawah dia 3 plus cos x, okay. Kalau awak check kat sini, one by one, there is no formula to integrate this function. Okay, I mean no direct formula. Okay, so kalau tak ada direct formula means maybe we can try with u substitution. So if we try using u substitution, what should we choose the correct function for u? Okay, so kalau awak tengok dekat sini, kalau kita differentiate cos, kita akan dapat sinh. Okay, so u yang sesuai adalah yang bawah ni. Okay. Okay, so use integration by u substitution. So u kita adalah 3 plus cos x, and then every time when we use u substitution, after we identify u, we need to find du over dx. Okay, kita differentiate 3 constant dapat 0, and then plus differentiate cos x, we got sinh x, positive sinh x. And after that, we need to write dx as a subject. Okay, so we just cross multiply. So we got dx equals to du over sinh x. Alright. After that, we need to rewrite this question in terms of u and du. Okay. Right. So from here, okay, we have denominator equals to u. Okay. Our u equals to 3 plus cos x, okay? And then in numerator, we still have sinh x. And then times dx. We write dx equals to du over sinh x, right? Okay, dan kita tengok ni sama lah. Okay, so we can simplify sinh x in numerator and sinh x in denominator. Okay, after that we got this. Okay, integration of 1 over u and then du. No more variable x. Okay, tinggal u and then du saja. So ini tanda-tanda betul. Okay, tanda-tanda teknik kita tu betul. Right? Alright. After that, okay, to integrate 1 over u du, kita boleh refer from appendix formula number 2. Tapi yang ni variable x, okay? If we integrate 1 over x dx, the answer equals to ln modulus x plus c. So kalau variable sekarang u, okay, we integrate 1 over u du. So the answer equals to ln modulus u plus c. Okay? And after that, we need to replace u in terms of x. Okay, kita guna yang ni. So we can write ln modulus u kita adalah 3 plus cos x. Okay, and then plus c. Okay, tapi ini baru indefinite integral. Okay, soalan tanya definite integral. Integrate from 1 to 2. Okay, so to evaluate integration from 1 to 2 sinh x over 3 plus cos x dx, kita ambil saja jawapan yang tadi ni. Okay. So equals to ln and then modulus 3 plus cos x, tapi tak ada plus c. Plus c ni for indefinite integral. Okay. When we evaluate definite integral, we must put lower limit and upper limit. Okay. And must put square bracket. Alright. Lepas tu, we must substitute upper limit first. Okay. We substitute into variable x. Okay. And then in between must minus. Lepas tu kita gantikan pula x yang ni dengan lower limit. Right? And then you just tekan calculator. So the final answer equals to 0.3977 up to 4 decimal places. Right? Okay, so this is the complete solution for this question. Right? Got it? Alright, next, we continue with question number 11 in page 118 from lecture note, buku ni. The question is, integrate x inverse cos 2x squared dx. Okay. Okay, ni soalan dia. Okay, first kita buat apa? Let's say we try to check from appendix. Okay. This is the appendix, okay, yang kita akan guna dalam, you akan dapat masa final nanti. Okay, so kita check, ada tak formula untuk integrate inverse cos? Okay, kita check one by one. Okay, kalau you tengok dekat sini, there is no direct formula to evaluate integration of inverse cos. Yang ada kat sini hanya integration of ordinary cos. Okay, so oleh sebab tak ada dekat sini, kita kena buat apa? Okay, kita check pula yang dalam bracket ni, degree yang ni x dia degree 2. Yang luar ni x dia degree 1. So dia ada kena mengena dari segi derivative. Okay, so oleh sebab ada kena mengena dari segi derivative, so maybe we can use u substitution. Right? Okay, so we integrate using u substitution. Okay, tapi dalam kes ni saya pakai t dulu. Okay, kenapa saya pakai t? Sebab kalau tengok dekat sini dia macam panjang lagi perjalanan dia. Okay, so saya pakai t dulu. Alright. Dia sama je lah macam u substitution tapi just guna variable t. Okay, so from here our t equals to 2x squared. Okay, every time when we use u substitution, I mean in this case t substitution, we need to find the derivative. Okay, means we differentiate t with respect to x. So we got dt over dx equals to differentiate 2x squared, we got 4x. After that, we need to write dx as a subject. So we got dt over 4x. Alright? Then we substitute back into the given question. We write in terms of t and dt. Okay? Okay, so it is equals to integration of, we still have x here, and then inverse cos, and we replace 2x squared by t. Right? And then we write dx equals to dt over 4x. Right? Okay, and then from here we have x, and then we also have x in denominator, means we can simplify. Right? And at the same time, we can move out over 4. Okay, we move from integration sign. So we got this. Okay, we have 1 over 4 integration of inverse cos t and then dt, no more variable x, sebab kita dah simplify tadi. Okay, so now we only have variable t and dt. Okay, ni tanda-tanda betul lah sebabnya kita dah berjaya hapuskan variable x, tinggal variable t sahaja. Alright, dan kita check lagi. Ada ke formula nak integrate inverse cos? Okay, tadi kita dah check kan? And there is no direct formula to integrate inverse cos. Okay. So, yang ini sebenarnya kita kena guna integration by parts. Okay, sebab yang soalan yang ni memang tak sesuai lah nak pakai integration by partial fraction, integration by trigosa. So, yang sesuai adalah integration by parts. And then, every time when we integrate using integration by parts, we need to identify the suitable function as u. Okay, so in this case, we only have single function, okay, which is inverse cos t. Means we can replace inverse cos t equals to u. Okay. Okay, so kalau dah inverse cos t equals to u, so automatic dt equals to dv. Okay, bila kita guna integration by part, kita kena tulis bentuk u dv. Right? So, inverse cos t as u and our dt equals to dv. Alright? Okay. Lepas kita dah tulis formula integration of u dv, kita still ada 1/4 kat depan ni. Okay. And then, using by part formula, okay, integration by part formula, integration of u dv equals to uv minus integration of v du. Okay, this is the formula for integration by parts. Okay, dekat depan ni kita still ada 1/4 and then we expand first. So we got 1/4 uv minus, kita darab ke dalam, 1/4 integration of v du. Okay. Okay, tadi kita punya u kita adalah inverse cos t, dv kita adalah dt. So, kita tulislah kat sebelah dia. Okay. Our u equals to inverse cos t and dv equals to dt. Alright. Okay. Using integration by parts, from u, we need to find du. Kena buat apa? Kena differentiate. Okay. And then from dv, we need to find v. Kena buat apa? Kena integrate. Alright. Okay. So, to differentiate inverse cos t, dia ada formula dia. Formula dia adalah 1/square root of t squared minus 1. Okay. Dekat sini patutnya kita ada du over dt. Tapi over dt ni kita move to right hand side. So, we got times dt. Kenapa? Sebab dalam formula kita hanya nak du. Kita bukan nak du over dt. Sebab tu kita write du as a subject. Okay. And then from dv, we need to find v. We need to integrate. Okay. Okay. dt sahaja means 1 dt. Integrate 1 with respect to t equals to t. Okay. Alright. Ataupun nak senang, you just close d for both side. You tutup d dua-dua belah. So, yang nampak hanya v equals to t. Right? Alright, in the previous slide, we stop until here. Okay. Before that, from here, first we use u substitution ataupun dalam kes ni saya pakai t substitution. Okay. Saya gantikan t equals to 2x squared. Okay. Lepas dah ganti tadi, and then we can simplify x here and x in denominator. And then at the same time, we can move out over 4. Okay. From integration sign. So, we got 1/4 inverse cos t dt. And then from here, we can use integration by parts. Okay? And then when we use integration by parts, we choose inverse cos t equals to u. That's why tadi saya pakai simbol t masa yang sepatutnya u sub tadi. Okay? Sebab nanti dalam by part ada sekali lagi nak pakai simbol u. So, takut you confused. Takut awak confused. Right? Okay, so when we use integration by parts, we need to write in terms of integration of u dv. And then from formula, under integration by parts, integration of u dv equals to uv minus integration of v du. Kita still ada 1 over 4 in front here. And then we expand 1 over 4, so we got this. Right? Ini dalam previous slide. Saya ulang balik sebab tadi tak muat dalam satu slide. Okay. And then tadi kita dah discuss our u equals to inverse cos t, dv equals to dt, and then from u we need to find du, we need to differentiate, and from dv we need to find v, so we need to integrate, right? Okay, so lepas dah dapat u, du, dv, dt, kita masukkan dalam formula ni. Okay, then we got this. Okay, we have 1 over 4. Okay, so u darab dengan v, u darab dengan v. So we got t inverse cos t. And then we have minus here, 1 over 4. And then we have integration sign. And then v darab dengan du. V darab dengan du. Means t darab dengan 1 over square root of t squared minus 1 dt. Right? Okay, yang ni there is no integration sign. So, no need to integrate lah. Kita just salin je. And then, we have minus 1 over 4, constant 1 over 4. T ni is variable, so we cannot move out. Okay? Remember, never move out variable from integration sign. Yang boleh pindah keluar hanya constant sahaja. Okay? So, yang ni kita dapat T over square root of t squared minus 1 dt. Right? Okay. Macam mana kita nak integrate yang ni? Okay. Yang ni no more integration sign, so tak perlu integrate. Tapi yang ni ada integration sign. Remember, when we use integration by part, dalam integration, ada lagi integration. Okay. Okay. So, to integrate t over square root of t squared minus 1 dt. Okay, yang ini kita boleh guna u substitution. Okay. Tapi u yang ni dia tak samalah dengan u yang ni tadi. Okay. Okay, u substitution. Ataupun sebenarnya boleh juga nak guna trigonometric substitution. Tapi panjang sikit lah. Okay. Kenapa boleh pakai trigosub juga? Sebab kita ada bentuk radical kat sini. Okay. And then dalam radical tu kita ada t squared. Okay. Okay, ataupun dalam biasa kita pakai variable x, okay, tapi yang ni variable t. Okay, so we can use integration by u substitution. Kenapa? Sebab degree atas ni, t ni, dia kurang 1 daripada degree bawah ni. Okay, so dia ada kena-mengena dari segi derivatif. Okay, okay, so our t kita, okay, kita pakai T substitution, u substitution, tapi sebab tadi kan dah pakai u kan masa integration by part tadi. So yang ni saya pakai z lah pula. Okay. Okay. So z equals to t squared minus 1. Okay. And then every time when we use u substitution, I mean in this case z substitution. Okay. We need to differentiate. Okay, we have z and variable t. So after we differentiate, we got dz over dt. Okay, differentiate t squared with respect to t, we got 2t. Differentiate minus 1, we got 0. And then we write dt as a subject. So we just cross multiply. So we got dz over 2t. Okay, and then we substitute into this integration. Okay, now we want to evaluate integration of t over square root of t squared minus 1 dt. Okay, okay, so kita rewrite in terms of variable z and dz. Okay, so we got integration of t, kita still ada t ke atas, and then over, and then we have square root symbol. Okay, our z tadi equals to t squared minus 1. Okay. And then we write dt equals to dz over 2t. Okay. And then awak tengok kat sini, ada t kat atas, ada t kat bawah. So, we can simplify t. And then at the same time, we can move out constant over 2. Okay, kita pindah keluar. So, we got half and then integration of 1 over z dz. No more variable t. So, tu tanda-tanda betul lah tu. Okay, sebab tinggal variable z dan pasangannya dz. Okay, so how to evaluate integration of 1 over z dz? Okay, yang ni kita kena move up dulu using properties of indices. Dia akan jadi z to the power of negative half. Okay, and then since dia punya exponent ni not equals to negative 1, so we can integrate using power rule. Okay, under integration, when we use power rule, means we need to add 1 from the original power. Okay, kita tambahkan 1. So, negative half plus 1 equals to positive half. And then we perbalik, okay, dengan kuasa yang dah tambah tadi. Okay, per dengan half. Dekat depan ni ada half juga. Okay, so kita ada half kat sini, half dekat sini. So, we can simplify. Okay. Okay, and then after simplify half, we got z to the power of half plus c, and z to the power of half ni means square root of z plus c. Okay, tadi our z equals to t squared minus 1. Lepas tu kat luar kita ada square root and then plus c. So, ini adalah bila kita integrate t over square root of t squared minus 1 dt, dapat jawapan yang ni. Okay. Okay, so kita boleh tulis kat sini. Okay, so we have 1 over 4 t inverse cos t. Yang ni no need to integrate because there is no integration sign. And then minus 1 over 4. Okay, tadi kita integrate yang ni. Okay, kita dapat yang ni. Okay, so kita letakkan dekat sini. Alright. And then dah habis dah integrate. So we put plus c at the back. Okay, because this is indefinite integral. Okay, lepas tu kita gantikanlah t tu kat sini. Okay. Okay, lepas kita dah ganti integration of t over square root of t squared minus 1 dt equals to square root of t squared minus 1, and then we put plus c at the back because this is indefinite integral. Okay. Okay, sekarang yang ni no integration sign, so no need to integrate. Okay. Yang integrate yang ni tadi dapat yang ni. Okay. Tapi kita check balik from original question we have variable x. Tapi kita dapat jawapan dalam variable t. So, kita kena replace t in terms of x. Okay. So, kita guna yang mana untuk gantikan t in terms of variable x? Kita guna yang ni. Okay. Kita guna yang ni. T equals to 2x squared. So, kita replace t yang ni. Okay. T, sini pun t, sini pun t. Gantikan dekat sini. Okay. From t equals to 2x squared. So, kita gantikan dekat sini. Okay, t, kita replace by 2x squared. T yang ni pun sama, replace by 2x squared. T yang ni pun sama, replace by 2x squared. Tapi dekat luar, kita ada squared lagi. So, kita simplify. 2 and 4 ni boleh simplify jadi half. So, we got half and then x squared inverse cos 2x squared minus 1 over 4 square root of 2 squared equals to 4. X squared squared lagi equals to x to the power of 4. And then minus 1 and then plus c. So this is the final answer when we integrate this function. Okay. So banyak step dia. Mula kita pakai u sub tapi kita pakai variable t. Lepas tu kita kena integrate using integration by part. Okay, lepas by part, dalam by part ada simbol integration lagi. So, kita kena integrate lagi sekali pakai U sub. Tapi sebab dah guna variable U masa by part tadi, so this time saya guna Z pula. Okay. Lepas tu, bila dah integrate ni, saya tunjuk kat tepi. So, kita masukkan dekat sini. Tapi kita dapat dalam jawapan, dalam variable T. So, you kena ganti balik. T tu equals to 2x squared. And then simplify. And then dapatlah jawapan yang ni. Right? Got it? Thank you.